Venn diagrams, the thing we use to present frequency of independent events. Let's first talk about the dreaded set notation, which people forget. First thing we need to do whenever we draw a Venn diagram is put it in a box, right? You can put a zeta here, or Cauchy, as my structural engineering professor likes to call it, Cauchy. We got A, B, and we got two circles representing A and B, right? Let's first talk about what A is. Whenever we talk about the probability of A, that is just going to be everything in A, including the intersection. Which means, you guessed it, the probability of B is going to be everything in B, right? But what about everything in total, right? So if we have another go at a Venn diagram, right? We put A here, B here, zeta. The probability of not A, right? This is what we call not A, okay? Because it's everything that's not in A. Yeah? Because it's not in A. Another form of set notation you need to learn is the U's, as some students like to call it. The N or the U. Which one is it? Let's first talk about this part in the middle, right? This is called, if this is A and B, this is A intersection B. So if anything, right, you can think of it as intersection. Okay, and the other one, which people ask about and forget, is a union B. Which is just everything in the middle. Okay? And if this is A and B, and then this is Cauchy, then A union B is everything in the Venn diagram. Okay? These are the four fundamental ways that you can write your set notation, and everything else is just a combination stroke realignment of these core set notations. A union B, A intersection B, probability of A, probability of B, and the probability of not A. Is this making sense so far? Well, make sure you subscribe so you never miss another video from me. Now let's look at an example. Here we have a cafe which records how many people like their chips. Altogether, 32 take salt, 45 take vinegar, 12 take both, and 11 take neither. Complete the Venn diagram. Okay, so we're told that 12 people take both, 11 take neither. Okay. We're told that 32 take salt, okay? Which means that of all the people who take salt, 12 take both salt and vinegar. So therefore, this number is just going to be 32 minus 12, which is just 20. And for the other one, we told 45 represent vinegar. So 45 minus 12 is equal to 33 that take just vinegar and nothing else. Okay? How many total people were surveyed? That's just adding up the total in the Venn diagram, which is just, let me actually do this in a different color, 11 plus 12 plus 20 plus 33, and what we're left with is an answer of 76. Okay, so we have all the numbers in the Venn diagram. Now let's work out the probability of picking somebody whenever we are looking at the Venn diagram. The probability of S, remember what the probability of S is, right? The probability of S is, I'm going to use my highlighter, is everything in here. I don't know if you can see that. I'm going to try a different color. Is everything in here, okay? Absolutely everything. So the probability of S is equal to, how many are there in total? There's 32. So 32, and how many are there in total? 76. So the answer is 32 over 76. If you want, you can indeed simplify the fraction. With probabilities, you don't have to, but if you want to, you can simplify that to be 8 over 19. That also works. Okay? Now, what about the probability of S intersection vinegar, right? I'm going to highlight this in red. All right. So that's this one. Remember, because it's intersection, it's going to be in the middle. Okay? Everything in the middle. And how many are there in the middle? There are. I'm going to rewrite it because we've run out. It's fine. There are 12 in the middle, isn't there? So let's write down 12 again. And we know that the probability is going to be 12 over 76. Which simplifies to, if you want to, 3 over 19. Okay? Now, the probability of S union V. Let's look at the notation. What does it represent? It represents everything in the Venn diagram. Okay? So, everything. Right? And how much is there in the Venn diagram? Well, we know that there's 11 out, so it's going to be 76 minus 11, right? Because 76 is in total, 11 is on the outside, all divided by 76. And so what we're left with is an answer of 65 over 76. Okay? And that is our final answer. Do you guys need more help with this topic? Make sure you join my Discord down below to ask me whatever questions you want for fast responses, guaranteed. Now let's look at crafting our own Venn diagram and also finding the probability. 21 people traveled to a meeting. 12 used a train, 6 used a car, 7 didn't use a train or a car, and some used a train and a car. Okay? 2 of the people are chosen at random for those who used a train. Find the probability that those people also used a car. Okay, so the first thing we need to do is to draw a Venn diagram. We've got Koshi, which represents people traveling. We can draw a box. And we got one for train and one for car. Alright? We're told 12 people used a train, 6 people used a car. And 7 didn't use either. So let's put 7 on the outside. Okay. We know that 12 plus 6 is 18. Right? And we know that there are 21 people in total. Okay? So all we need to do to find the intersection, T intersection C, that's just going to be 18 plus 7, right? Because that's the total, minus however many is actually the total, which is 21. So that's just going to be 25 minus 21, which is equal to 4. So this is going to be 4 people. Now we must minus 2 on each of them. So the ones just in in T, that's just going to be 12 minus 4, which is equal to 8, okay? And for this one, it's going to be 6 minus 4, which is equal to 2, okay? And if at any point you are unsure as to if you're correct, you can just add them up. 7 plus 8 plus 4 plus 2 is equal to 21, okay? Awesome. We know that this is correct. Now we need to work out the probability of both these people also using a car, but we're also given that these people used a train. So out of the people who used a train, now we're going to use a tree diagram. So if this is T and this is C, we know that there's 12 people in total who used a train. Okay? The odds of them just using a train is going to be 8 over 12. And then it's going to be 4 over 12. And if they're using a car, then we need to work out, this will be 7 over 11, 4 over 11, and this will be 8 over 11. But what we're interested in is this one, car, which is going to be 3 over 11, okay? The probability of them both using a car, given that they are using a train, is going to be 4 over 12 times 3 over 11, which is going to be 12 over 132. And if we divide 12 on each side, we're just going to get 1 over 11. Okay? This is something called conditional probability when you're given that they are using a train, but we'll talk about that in the next video. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me by dropping me an email. We can organise a meeting and a quote. Keep on learning as you have no idea what you're